So some of the reasons why you'd want to perform live collections is that you'll be interested in things like collecting encrypted data, right? So the decrypted version of encrypted data, right? You want to perform memory collection, get information on running processes or services that are on the system. You'll be dealing with software RAIDs or RAIDs that are managed by the operating system rather than by a hardware RAID controller. We'll talk about that a little bit. There may be restrictions by the court, and a couple of the search warrants that we went on for some various government agencies is that the search warrant basically said that we couldn't disrupt business operations or had to have minimal disruption to business operations. So they had intermingled the suspect group had legitimate business and illegitimate business, but they were running on the same server, right? So what the judge basically said was, you can't disrupt these legitimate businesses just for the illegitimate ones, right? Then you're basically putting these legitimate ones in potential monetary loss and things like that. So we were basically kind of put in a situation where we needed to perform live data collection on these systems. You also may be dealing with systems where you're having one or more systems running on that physical machine, and this becomes very big when you're dealing with cloud environments, things like ESX or Xen or Microsoft's Hyper-V or other cloud-based platforms where you're going to have more than one system, and you kind of get confronted with the same scenario, right? You may have legitimate systems running alongside illegitimate ones. So there are some risks for performing live collections, and I want to make that clear, right? And to preface that ahead of time, you are altering data, right? Every action that you take on the system is being registered in some way, shape, or form, right? It is modifying something, right? And so the other thing to consider, though, is that systems are always changing. When they're up and running, they're constantly changing. If you were to look at like Process Monitor or something like that on one of these systems right now, you'd see just this rapid list of things that are actually occurring on the system. The operating system is constantly working, and this is where it basically comes into play. And this is why documentation is important, to kind of verify the actions that you took and that you can kind of lay out, this is what I did, right? So that you can basically use it as justification later on. You will have more scrutiny of the data, right? It will be a defense attorney's job to say that you did something wrong, that this was not done the right way. And the reason is because it's not possible to get an exact duplicate of your process, right? If you were to take power off the system here, pull out the hard drive and image it, and then I was to image it, we should get the same hash. On a live system, that'll never happen, right? And if it does, you probably have some sort of issue there anyways. But it's the type of thing where it can't, because the system is always changing, you're not going to be able to get an exact duplicate. That's why documentation of your process is very important. You also have to deal with things like remote access, right? If this is a system that's still connected to the internet or something like that, or you can't disconnect from the internet because of the reasons that I talked about before, you need to be concerned about the fact that somebody may be accessing the system, deleting files or whatever else. You also need to be worried about data corruption because you are accessing a system where files are being accessed. So you need to make sure that really the thing that I want to say here is that after you've imaged it, check it. Make sure that you actually have a file structure that looks right, because if you don't, then you'll probably want to go do it again, right? You don't want to walk away, go back to your lab and go, oh crap, I have a bunch of garbage here. It's also, be careful what you click on, because this is a live environment, right? You are making changes, right? Don't perform your analysis at this stage, because it's really just not the spot to do it. So kind of quick breakdown of what, kind of hardware and software RAID, for those of you who aren't entirely familiar. Hardware RAIDs are handled by a RAID controller, by a hardware device that is actually, built into the motherboard, which actually handles kind of the allocation of data between the disks, right? For those situations, you're probably going to be, if you can bring the system down, you're going to want to use something like a Linux boot disk, like Kane or Helix or Raptor or any of the other ones that you're familiar with. Basically things that are designed to do forensic imaging, because they're going to have the device drivers to handle those RAID controllers, and then you can image them that way. With software RAIDs are handled by the operating system. So the RAID management is actually done by the OS, like Windows or Linux will handle actually performing the RAID configuration. And that means that as soon as the operating system isn't there, the RAID configuration is basically not handled anymore. That's not to say that you can't piece the disk back together, right? Because you could, right? It is possible to do. But it can be more difficult. So you may want to actually consider imaging a system live if you're dealing with a software RAID. And there are some examples there. We'll talk about that a little bit more, or at least it's in the slides. It's available if you want to check it out.